Today's topic is standard form quadratics, I-CAN statement, graphing quadratic functions in standard forms using technology. You will want a graphing calculator while watching this video. Vocabulary. Standard form is one way to write a quadratic function. It looks like this. Y equals ax squared plus bx plus c, where a, b, and c are going to be numbers. In standard form, there are a few things that you can find. These are the key parts we talked about last video. Some of them are very easy, such as the extrema. If you remember, extrema is if it is a maximum or minimum. We can do this by looking at the value of a. If a is positive or if a is negative, it will tell us if we have a maximum or minimum. If a is positive, the parabola will open up like this, and if a is negative, it will open up like this. So it's opposite of what you would think. If a is positive, you have a minimum, and if a is negative, you have a maximum. Another easy thing to find is the y-intercept. The y-intercept comes from the value c. You just need to write it as an ordered pair, 0, and whatever c is. Another thing you can find is the axis of symmetry. If you remember, this is the invisible line that cuts the parabola in half. We can find it by using a simple equation, x equals negative b over 2a. If you plug in those values and solve, you will have the axis of symmetry. And the last thing you can find in standard form is the vertex. If you notice from the last time that the axis of symmetry will go through the vertex, meaning they share the same x value. So whatever the axis of symmetry is, it's the same x value for the vertex. So you only need to find the y value of the vertex, and you can do that by taking whatever x is and plugging it back into the equation. Example 1, we are going to solve for vertex, axis, symmetry, extrema, and y-intercept. I'm going to start with the easy stuff, extrema. The extrema is determined by the value a. A is a negative 2. If you remember, it's opposite, so if it's a negative, we're going to have a maximum point. Y-intercept, you just need to look at the value c. So my y-intercept is 0, negative 30. Axis of symmetry, we're going to use that little formula to solve for x. X equals negative b over 2a. Let's plug in. B is 16, so negative b would be negative 16, over 2 times a is negative 2. That's negative 16 over a negative 4, negative divided by negative. My axis of symmetry is going to be x equals positive 4. If you have the axis of symmetry, you're halfway there to finding the vertex. The x value of the vertex and axis of symmetry, same value. So to find the y value, we're going to plug in 4 for x. So back to the original equation, y equals negative 2, but instead of x squared, 4 squared, plus 16, instead of x, 4, minus 30. So we just need to evaluate. Y equals negative 2, 4 squared is 16. 16 times 4 is 64, minus 30. Negative 2 times 16 is a negative 32, plus 64, minus 30. If you combine all of those, we're going to get a y value of 2. Example 2, we're going to try it again. If you can solve for any parts on your own, pause the video and try it. Extrema. It's from the value a. This a is hidden because it's an invisible 1, but it's a positive 1, so think opposite, and you have a minimum. Y-intercept, c value, so 0, 9. Axis of symmetry. Using that equation, you want to memorize this. X equals negative b over 2a. b is 6, so it's going to be negative 6 over 2 times a is 1. Negative 6 divided by 2, we're going to have an axis symmetry of negative 3. And last, vertex. If you have the axis symmetry, you already have the x value of the vertex. So we're going to plug in negative 3 anywhere there's an x. Y equals, instead of x squared, negative 3 squared. Plus 6 times negative 3 plus 9. Now negative 3 squared means negative 3 times negative 3, giving me a positive 9. 6 times negative 3, negative 18 plus 9. 9 minus 18 plus 9 gives me a y value of 0. Okay, review of graphing. You're going to want to be using a graphing calculator. For the rest of the year, I recommend either renting one from the library, using an online one, looking out apps on your phone, or coming and using one before and after school. All of the gray buttons are graphing buttons. The button we're going to be using the most is y equals, because that's where you're going to plug in the equation. Then you can push the last gray button, graph, and you'll see a basic outline of the graph. But to see actual values, you're going to use the blue button above graph, which is labeled table. To get to it, you need to push the second button, then the graph button, and you will see the XY table. Example 3, we're going to solve for the same things, then graph. If you can do the solving on your own, pause and try it before watching me. Easy stuff first, extrema. A is an invisible 1, so positive, giving me a minimum. Y-intercept, value of c, so 0, 7. Axis of symmetry, we're going to use that little equation. X equals negative b over 2a. Negative 6 over 2 times 1. So that gives me an axis symmetry of x equals negative 3. Halfway to finding the vertex, same x value, plug in to find the y value. Y equals negative 3 squared plus 6 times negative 3 plus 7. If we go through and solve this, we will get that y equals negative 2. Now we need to graph. When you're graphing a parabola, you need to graph at least 5 points. Let's start with the points we already have. The vertex, negative 3, negative 2, right there. And then we know that the axis of symmetry is the invisible line that goes through that point. And it's going to cut the parabola in half symmetrically. This helps us find some extra points. So I'm going to start with the y-intercept at 0, 7. But because it's symmetrical, I know it has a matching point on the other side of the axis of symmetry. We can find that by counting over. My y-intercept is 1, 2, 3 points to the right. So if I go 1, 2, 3 points to the left, I have a symmetrical point. They're even on both sides. So I've got 3 points. I need 2 more. To find those 2 extra points, I can use my graphing calculator and go to the table to find those points. So type in the equation to y equals, push graph, then push second table to see the values. We have quite a few values we can use. I'm going to use the value negative 2, negative 1, and its symmetrical point, negative 4, negative 1. Now that's 5 points, but you can even keep graphing some more if you want to, enough to know that the shape is going to be a U shape, so it's going to curve down and curve right back up. Ooh, not very pretty there. Let's undo that one. Curve down, then back up, much better. Arrows on the ends. Try as much of this problem on your own. Try to solve and graph before watching me solve it. So pause it and give it a try. extrema. It's a negative, so I have a maximum point. Y-intercept, use my C value, so 0, -8. Axis of symmetry, we're going to be using this equation all year long, get used to it. Negative B over 2A, so it's -8 over 2 times -2. That's -8 divided by -4, giving me an axis of symmetry at a positive 2. Vertex, halfway there. The x value is the same as the axis of symmetry. Plug in to find the y value. So back to the original equation. Y equals -2 instead of x, 2 squared plus 8 times 2 minus 8. If I go through and solve this carefully, I will see that my y value of my vertex is at 0. Pause and try to graph as many of the points you can using your graphing calculator in the table to fill in the missing parts. Vertex is at 2, 0. Knowing that my axis of symmetry is going to cut it in half. Y-intercept is at 0, -8, so I also have its symmetrical point for -8. Still missing at least 2 more points to give me the 5 points. So I can graph another point. Looking at my table on my calculator, I can use 1, -2, and the symmetrical point 3, -2. Once I have 5 points, I can draw my U shape with arrows at the ends. Okay, can you find the key parts of a parabola in standard form? Can you graph the parabola using technology or graphing calculator? If you need more help, come in, watch the additional videos, or rewatch this video.